Good evening. My name is Gavin Yakukomi, and you are welcome to my channel. Today I'll be presenting on input-output devices. Okay, so what do you mean by input-output devices? So when you have your keyboard is an input device, your mouse is an input device, then there's also an output device, which is what? Your printer is an output device, your monitor is also an output device. So it's something that you need to keep in mind. Okay. Now, it consists of two parts. The output device consists of two parts. The controller, which is the electronics portion of it, okay, and then the device itself, okay. And let's take hard disk drive for instance. Okay, so the job of the controller is actually to control the device, okay, and then handle the bus access. That is the job of the controller, and that's actually it. Does that mean that when the IO device wants to access memory, it needs to do it through the CPU? No, that is not the case. And so that would have been very slow if we had used that option. And that would have been very, very disastrous. Let me use that word, disastrous, if we had been if we had used that option. Because let's take hard drive for instance. The hard drive actually spins. Okay, and when you want to use a CPU for that access, it actually means that it has to stop spinning and then the CPU will do the access and then come back to it and then that will actually slow the process. And so now priority is given to the input output device to have access directly to the main memory. And that is one thing that we also need to take a closer look at. Okay. And so it's something that we call direct memory access, DMA. And you need to take a closer look at this description. And the acronym is what? DMA. Now, in when the IO device is actually accessing the memory, it needs to, because the CPU will also be using the memory, it needs to what? Cause a stop there. And that is what we call the interrupt. And the controller will do that, okay, forcing the CPU to actually suspend whatever process that it is doing. The CPU in turn also comes up with another process, what we call the interrupt handler, that handles whatever operations that the IO device does. And so it checks for any errors, okay, and it take any special action that is actually needed. And when it's done that, it actually informs the operating system that the IO device has actually finished whatever it's supposed to do, and so we can resume, right? And so that's something that you need to also understand. Now, the conflict is what I talked about. Who accesses the memory first when I want to use it? Who? And then all of us needs to use the memory. Priority is given to who? And so that is a work of what we call the bus arbiter. And that the bus arbiter actually gives priority to the IO device to have access to the memory. And so we need to take a closer look at that one as well. So there's what we call the cycle stealing. You know that the CPU has a bus to all itself. Yes, the CPU has the bus to all itself. Now, when there's no IO device actually accessing the memory, okay, or doing any other thing. Now, what if it wants to access the memory or it wants to do any other thing, perform any operation? Does that mean that the CPU will still be doing its process and then leave the IO device to wait before it's done? No. Okay. And whenever an IO device requests for the use of the bus, as and when it needs it, the CPU immediately stops whatever it is doing and then grants access to the IO device. And this is what we call cycle stealing. Okay. And it slows down the computer a lot. And it slows down the computer a lot. And so you need to also keep that one in mind. Okay. All right. So that brings me to the end of my presentation. Thank you very, very much.